Hello, welcome everyone. We're going to give people a little bit of time, just a minute or so to file in. All right, well, let's get started. And, if people join in later, that's okay. The recording will be available afterwards. We'll make sure to send you the recording, so no worries if you need to drop off. Feel free to, reach out with questions later as well. So welcome everyone to Groundlight's Custom Object Detection and Counting webinar. We all know and love Groundlight's binary capabilities, binary mode, and so we're excited to be rolling out our counting capabilities. And I'm here with a couple of members from our science team, Dr. Paulina Varshavskaya, as well as Dr. Amiraza Farnoosh. And I will let them introduce themselves. Maybe Paulina, we'll start with you.
Hi, thank you, Julia. Thank you, everybody, for coming to the webinar. My name is Paulina Varshavska. I am the Chief Science Officer at Groundlight. I have a PhD from MIT in electrical engineering and computer science, and my background is in machine learning, robotics, and image processing. Really excited to be here launching this feature for you.
Hello, thank you, Julia and Paulina. I'm Amiraza Farnoosh. I got my PhD in electrical engineering from Northeastern University in Boston with a focus on supervised machine learning and deep generative models. And I'm currently working at Groundlight AI as a computer vision scientist.
The funny thing I just realized is that you guys got your PhDs, but I did my undergrad in Boston. So here we are from Boston, all of us in Seattle. I'm even wearing my undergrad t-shirt, which is really funny. Just made that connection. Yeah, thank you guys so much. Before we get started, a couple of housekeeping things. If you have questions, you're welcome to drop them directly in the chat, or I think we have a questions functionality. And also in the chat, you will see a promo code, GKULR, and I won't read the rest of it, but and I'll send you instructions on how to apply this code. But for you to use counting function and for you to test it around, you're going to need a business level account. And so if you sign up for Groundlight today, you'll start with the free account. So all you really need to do is copy this code, go to dashboard.groundlight.ai, go to your account, click your username. If you can click the video again, could you expand that? Yeah, click your account, you'd click manage service plan, you'd click the business tier, and then you would enter promo code right there and apply it there. And that is how you'd have a free month of counting capabilities. We'll go over that again at the very end, but just wanted to say that very excited to offer this code for you. It expires on May 9th, so you will not be able to use this code after May 9th. So with that, we will get started on the actual presentation. Paulina, take it from here.
Great. So today we're going to give you a little bit of background on Groundlight, the company, and what we do and service we provide. Then we'll launch into counting custom objects and explain a little bit more in depth how it works, and then make sure you know how to get started with that. 1 second. Okay. So Groundlight, we're in Seattle. We were founded in 2019 by our two founders, Leo Dirac and Avi Geiger. We have a great team of engineers and applied scientists. And what we do is reliable AI vision, state-of-the-art computer vision that is backed 24/7 by human labelers, annotators, and monitors, if you will. So the models that we make work for custom problems and are trained on your data and work for you with that supervision. We work in many industries: industrial manufacturing, video management systems, safety, facility monitoring, and mobile robotics, and we're SOC 2 compliant, if that matters to you. So the way you can use Groundlight is either by buying a hub with a simple monitoring tool, so self-serve access for industrial and manufacturing applications that are pretty standard. We also provide fully managed solutions that integrate with your existing hardware, or we can provide new one. And of course, you can download our SDK and build your own projects, talking directly to our API, and we also have an ROS integration. So what we do for you is a fully managed computer vision solution. You don't have to worry about labeling. We have 24/7 human annotation. You don't have to worry about tuning your models and model selection. We provide the AutoML for you. You don't have to worry about MLOps. We do the continuous monitoring and evaluation and the deployment of the best models. And it's also available on Edge for scalable on-prem inference as well as on the cloud. So Groundlight unblocks some of the barriers in traditional computer vision by understanding the confidence with which the models answer your questions and escalating to humans when the model is not confident, whereby the model is also quickly learning from real-world experience and those labels that the humans provide. You know that if you've tried to write your own or train your own computer model and deploy it in the real world, that you spend a lot of time collecting data, labeling, training, deploying. You have a working application, finally, sometime later, days to months, depending on your application. And then something changes in the environment and the model isn't no longer appropriate and you have to start over. So instead of doing that at Groundlight, you deploy a working application and everything in that loop is abstracted away behind our API, and we do it on the fly, providing answers from humans at first, and then more and more from models as they learn. So this little loop that happens for every image query is that the model answers if it can, but if it cannot, it will escalate to better, bigger models or to humans. And as the humans answer, they train the models underneath them on the ladder. This is kind of our Groundlight real-time active learning implementation. You could go with traditional computer vision, machine learning, training, and evaluation, deployment loop. You need notes of data. It will be able to answer your questions. It will become very accurate for the particular scenarios that it has seen, and it can be fast. You could go a different way and send your questions to one of these VLMs, large language models, vision language models, and chatbots. You don't need a training set for that. It can answer any question, but can you trust the answer if the kind of scene and kind of question that you're interested in, maybe from some manufacturing situation of particular widgets that nobody has seen before. Was that available in the training set? Can it know what it's talking about? We don't know. And it's also, of course, slower and more expensive and only cloud-based. But the Groundlight is data efficient. It needs the key examples of ambiguous situations to be clarified by humans. It can be tuned, it will be tuned on your specific data, and it will provide fast answers when it can and escalate when it can't. So counting custom objects, I'm going to give it over to Amir.
Thank you, Paulina. Just give me a second to share my slides. Yeah, thank you. So Groundlight is great for counting custom objects that aren't typically recognized by off-the-shelf object detection models because they are not part of standard object classes found in typical object detection datasets. So let's take this inventory monitoring as an example. Let's say we want to count how many AI kits are on the shelf. These kits aren't standard classes you would find in most object detection classes. object detection datasets. And here we run multiple Groundlight modalities to do this application. First, we use an object detection model to identify all the items on the shelf. Then we crop each item and run a binary classifier to check if the person is touching the item or not. And finally, we apply some text recognition OCR to the cropped images to read the labels. And combining all these together gives us a complete picture of the inventory on the shelf. And here is the GitHub repo for the inventory monitoring application, if you would like to check it out. Here is also another example of counting different types of parts, like elbow connectors and three-way connectors on a conveyor belt in real time, specified with green bounding boxes. So these are industrial items that off-the-shelf object detection models usually haven't seen, so they wouldn't be able to detect them reliably. And here we are tracking these parts on the conveyor belt and count how many parts have passed through. We also can provide the velocity information for each item on the conveyor belt. This is also the Groundlight dashboard for this detector we use to for which we use to count the connectors on the conveyor belt. And it shows a summary of how many parts were found in the submitted images, along with whether the answer came from the ML model or a human labeler. And you can also click on any image to see the individual answers and who provided them, the ML model or the cloud labeler. And as another application, Groundlight can also be used to count objects with specific attributes. For example, in this application, we are tracking how many employees wearing blue Groundlight t-shirts enter or exit a room. So off-the-shelf object detection models do a great job detecting people, but they usually can't distinguish specific attributes like clothing without additional training. So here we trained a custom detector to recognize employees in Groundlight t-shirts. And on top of that, we run some simple tracking and count how many employees cross a virtual line, which is specified by the red line here. In the video, which gives us a reliable entry-exit count. And sorry, yeah, and here we have the we have the key moments from the video showing the ML model can reliably count the number of people entering and exiting the room, even when they come in large groups. As you see here in this specific video, a large group of people are exiting the room, and the model is able to handle this occlusion and reliably count these employees with Groundlight t-shirt. And here is also the repo for this application, if you would like to check it out. With that, I'll pass it over to Paulina to continue.
Thanks, Amir. So how does this work? Let me take you through some of what it takes to make these kind of models and custom detectors, custom counting detectors available. So you start, how it works from the perspective of the user is you start by creating a detector. You can do it through the dashboard, or you can do it through the Python SDK. It's just 2 lines of code. The important part is to specify the confidence threshold for the detector. Here on the slider, you see it's being dragged from 0.7 to 0.9. Roughly, this is the amount of time that it's okay for the model to be wrong. Sorry, but that it must be correct, right? So 1 minus that is how much it can be wrong. So if it's under 0.9, it will be answered, it will be escalated. If it's over 0.9, it will be answered by the model. So then the next thing you do is you send your images either through the interface on the web or through Python SDKs, another line of code. And then as the captured images come to the system in the back end, this model has been trained on recognizing birds and detecting birds. So the top image, it detects 3 objects that are birds and answers 3. It's over 90% sure, so it will return that answer because we set the threshold at 0.9. But then the second image comes from a squirrel that invaded this bird feeder at night. And the model has never seen anything like that before. It sort of looks like a bird to it. So it answers 1 bird, but is only 60% sure. Because that's under the threshold, it will get escalated to a person looking through our interface and reviewing this. And the person will say, no, this is not a bird. There are 0 birds in this image. And the model for that detector will learn from that answer. It will be added to the training set. So whether the answers come from the model or they come from the people labeling online, the output may arrive with a variable latency, but will have the same format and can be integrated with your analytics and insights in various ways. We provide integrations. The important thing is that over time, the model will require less and less, fewer and fewer of those escalations. This video is from a binary detector rather than a counting one, and is asking the question, is the person touching an item on the shelf? Over time, at first, it relies almost exclusively on human labeling. There's over 75% of the time we need to escalate the answer, but within 1200-ish frames, it's almost never. And the model is 99% accurate without having to bother anybody on the other end. So what that takes under the hood is a complex system coordinating machine learning and human answers. This diagram kind of traces your image in question as it arrives from the client application that sends images, which are routed to the yellow boxes that are different ways that questions can be answered. If you have an edge deployment, then there could be edge-optimized models that recognize this as an easy answer and return right away. If they're not sure, they could escalate to the cloud, which runs in a Kubernetes cluster. And inference workers run other machine learning models that have been trained on your particular detector, on your data and your scene. They may answer, and if they aren't sure, then that gets escalated through the labeling queue to maybe a large vision language model that can act as a labeler, or ultimately the gold standard is human judgment. If you want to look at everything that the diagram describes, the slides will be available later, so you can take another look. There's a lot going on. The most important thing for each detector is that multiple models are trained for every detector, so every question that you ask. For each detector, for every customer problem, we will pick the best model available automatically. We train multiple architectures as primary ML pipelines for each detector, here in green. Those 4 counting detectors would be based on object detection architectures like grounding Dino, or faster CNN, or CenterNet, or the YOLO family of models. And then from the label data available, there will be a training set and a calibration set for confidence calibration after the model has given its answer. We'll leave that one for a second. We'll talk about model selection. So on the training set, we train all of these models, but we also run a parallel cross-validation process. We use fourfold cross-validation. And based on that, we will pick the best currently available model of the ones we have tried, and that will be set as active. And in addition, we will also train auxiliary pipelines for each detector, those that can predict whether the model is, whether the image is objectively ambiguous or otherwise unclear, or if it is out of the main. And those will be integrated with the output of the primary model to make sure that it's not overly confident in situations where it shouldn't be. So we take care of model selection through constant evaluation. And then after the answer is given, we take care of deciding how to escalate based on confidence calibration. This is one of the most important aspects of the service. And Amir is going to talk about that.
Yeah, thank you, Paulina. Yeah, as we mentioned, confidence calibration is central to how our system works. It helps us decide which images are challenging for the ML model and should be sent to a human labeler for review. And by confidence calibration, we mean that if a model says it's 90% confident in a prediction, it should actually be correct 90% of the time. So out of all of those predictions with 90% confident, 90% of them should be correct. For our count detectors, we apply 2 layers of calibration, one for the objectness scores of the object detection model, and one for the confidence of the count value. For objectness score calibration, we fit 2 beta distributions to the objectness scores of true positive and false positive predictions from the object detection model. And the calibrated score is then the likelihood that a given prediction score came from the true positive distribution. We also calibrate the confidence in count value as a special case of discretized regression. So in a typical regression calibration, confidence intervals are adjusted so that, let's say, 90% of the predictions fall within the 90% confidence interval. And as you see in the figure on the right, the top, before calibration, more than 50% of the predictions, the dots, fall outside the 90% confidence interval. But after calibration, the interval is correctly adjusted to include about 90% of the predictions.
Yeah, and so thank you, Amir. And so this is what enables the Groundlight pipeline and the continuous escalation and training loop that we promise our customers. So how do you get started using it? Julia, take it away.
Yeah, thank you so much, Amir and Paulina. It is amazing the amount of, I guess, work that is behind what is a pretty simple user interface, but you can see that on the back end, the science team, they are constantly finessing, they are constantly fine-tuning, they're doing experiments to really see and improve basically all of the, what I think is kind of like the magic that happens on the end, the front end, or sorry, the back end. So you might be asking, okay, this is great. These are some interesting use cases. Now, how do I use the darn thing? You know, how do I start counting with Groundlight? So first, snag that promo code if you have not already done so, because you won't be able to use counting on a free tier. You will have to use on a business level account. However, I will show you 2 different ways to access the counting features. So the first is through our Python SDK. So our docs are available here. If you go to code.groundlight.ai, click docs, we have our getting started with Groundlight tutorial. And I will say I am not a developer by any means. I have a very beginner level knowledge of Python. And I was able to go through this tutorial successfully myself and create my own counting detector. It's pretty intuitive. It's very simple. It'll take you probably like maximum 40 minutes. So we recommend starting with a binary detector if you've never used our Python SDK before. You just simply pip install Groundlight. I'm sure, yeah, frame grab is in there as well. And then we are offering you a way to analyze eagles using a live stream video, a YouTube live stream. So you can use any live stream you'd like. We recommend this eagles. It's really cute. They just hatched some baby eagles, so you can actually see some baby eagles in there. If you want to get a little bit more in depth than just is there an eagle visible, you can even ask if the eagle is feeding the baby eagles. That is actually happening quite often. So from there, after you've created your binary detector, to use counting, you would click counting modes, and we have this count detectors page. So you can count how many cars are in the parking lot. And you can see the maximum count is 20. Confidence threshold here is quite low in the beginning. But again, this is kind of like the hello world version of getting started with Groundlight. So that is one way you can get started. However, what if you just want to kick the tires, instead of, you just want to quickly see if it's working? There is an easy way to do that. You can just simply upload the image, as Paulina said. So go to your account at dashboard.groundlight.ai. And when you get started, click Create New. And I'm going to call this banana. And answer mode, we have here count. So select count. And then you click Next. And I'm going to say label each banana in the image. And I'm going to set my confidence interval at like 70%. Maximum count here. And then you can add some notes if you want. Bananas are pretty straightforward. So I'm just going to click Create. And now I'm going to add an image. I'm just going to simply upload an image, bananas here. And essentially, this is not realistically how you would actually use, a working application, right? You're not going to be manually uploading images. You're basically going to be automatically sending sending the images to Groundlight. But you can see my banana image here, and you can see the algorithm has already answered that there are 3 bananas, which is pretty cool. So this is a really simple way to test out the image. And again, the key here is to well, actually, the interface is so simple. There's really no way to mess up, in terms of how you formulate the question. It's really just label each banana in the image. So I invite you to test that out. And with that, I will show you again how to apply your promo code, and then we'll finish with questions. 1 second, I will share my screen as well and go to the deck again. So how to apply the promo code. Promo code is this, but basically how you apply it is you go to your account, you click account on the top right, and then from there, you're going to click upgrade service plan. And then from there, you're going to click business get started. And then you simply enter in the add promotion code, you would add that code there. And then you should be set with using Groundlight for a month for free. So it's as simple as that. And with that, I think we're going to transition to questions. So I will stop sharing my screen. If I know how to do that. I'm no longer sharing my screen. So we're already good. Okay, so let's feel free to drop some questions in the chat. We flew through this pretty quickly, which is great. I always think shorter is better, short and sweet. So yeah, please let us know if you have any questions about using Groundlight's counting capabilities. Okay, let me look in the questions tab. Let's see. We have one question that has popped up. Let's see. This is a question I'm contributing actually. So I don't know if you guys can see my question that has popped up, but I am going to start a live answer. And the question I'm asking is, what are the most common counting use cases you see for using Groundlight? And I will say that this is a question we get a lot is like, okay, what are the types of applications that you would most recommend using Groundlight for counting? And so we, again, talked about how, beyond counting people, you can count, for example, if they're wearing employee uniforms, if they're holding shopping bags, you can count that sort of thing. But again, I think let's talk a little bit about the application of the conveyor belt here. Whiz by. Do, 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 do. So yeah, a question to you, Paulina and Amir, is, if I wanted to build this application using more traditional methods, what would that process look like and how long would that take me?
I can take that. Okay, so you have this, if you would have to film this conveyor belt for a while and you would have to break the video into frames, which you already are going to do to send this to Groundlight. But then what you have to do is draw bounding boxes around the parts that you're interested in. And the process of labeling that will take a while. Then you have to write the code to, there's many libraries you can use. It's not particularly complicated, but you have to decide which architecture to use. You have to decide which hyperparameters to use, and you have to train your model to locate these parts that you're interested in the image. And then if something happens, like the lighting conditions change and the conveyor belt changes color or something else happens, the camera, I don't know, then it might just not work and you have to retrain again. We hide all the work of that from you by using Groundlight. We're not, we're doing all the things that you would have to be doing by hand. And the other thing, of course, is if there's new parts coming in through, can you distinguish between them? That is also taken care of. Amir, do you have anything to add to this?
No, that was great. Yeah.
So you're saying, just throwing out a number there. I know it's kind of tough for you to say, but it sounds like it would take, at least a week or weeks to get this running.
I think if you already know what you're doing, it could take like a few days to get this running. The point is, how often do you have to do that?
Yeah. Okay, because like, for example, say I left a soda can on the conveyor belt on accident. The soda can, goes under the camera. So are you saying the model would break then?
It might. Every case is different. I don't know if I can give you an exact answer for this, but
okay, yeah. But it's not necessarily reliable, is what you're saying.
Especially in situations where something about the entire scene changes or enough of the scene changes in a way that makes the images substantially different than the training set.
Got it. Yeah. And I want to say, the really cool thing about this is that I asked Tim, our robotics engineer, our software engineer, hey, you have a conveyor belt. Can you just give me a little, like a quick demo? And he whipped this up in like, I want to say several hours, if not less. And probably most of the work took like setting up the conveyor belt. So that was really cool that, he was able to get that to me so quickly. Yeah, so I'm really excited about the applications that are possible with this mode. Okay, I'm just going to check to see if there's any other questions. Any other questions? Oh, I see a question here. For many of the examples, like the part and person counting, are all showing videos. Since the API is image-based, do you only recommend running these on Edge, or do you have applications like this running on the cloud as well? That's a great question.
This is a great question and very, very important to realize, especially in the beginning as you're training counting models. It takes a while for the human annotators on the cloud to draw the binding boxes, depending how busy your scene is. So you have to make sure that whatever answers you're getting, either you don't need them right away in the very beginning while the model is still really training a lot and asking for human feedback a lot, or that it's like a throwaway short period of time while this is happening. After that, if you want to process video at several frames per second, yes, you should run this on the edge, and we support that.
Yeah, and I think we'll probably be releasing some further announcements on that in the near future as well. But again, feel free to reach out to Groundlight because, of course, when you have parts passing in a conveyor belt, you're going to need to be capturing those images quite rapidly, right? So that's a great point. Another question, Paulina and Amir, I've heard, is like, okay, counting. How many things can you count? Can you count like a group of people, a crowd? Can I have a drone flying up and counting like an entire scene? What are the capabilities there?
Yeah, so currently we have a maximum of 25 counts. We kind of support like counting a handful of objects for now, for like efficiency matters. So we don't want to spend like too much time. The labelers spend too much time on drawing bounding boxes around like many objects. So we kept the maximum number of objects for now to 25.
And you mentioned drawing bounding boxes, and a question for you. Can I, as a user, draw bounding boxes as well? Is that something I can do?
Yeah. So, I mean, bounding boxes can be drawn by cloud labelers or human labelers. You can also like edit bounding boxes drawn by the labelers, or you can also provide your own labels. So it's a feature on the dashboard where you can like add labels to your existing images or edit the labels provided by the cloud labelers or just confirm those labels.
Julie,
Great.
you could probably go and do this right now on your banana example.
All right, let's go bananas. Haha, mom jokes at the finest. I didn't sleep well last night, guys. Sorry for that joke. That's not what I wanted to share. I wanted to share something else. Okay, share my screen. Yeah, that's a good point. Okay, so say here, I want to label this myself. I just click this pencil, right? And then I could submit 3 boxes. But say if I decide there's a banana over here, I know there's not really a banana over here, but I could, in theory, draw a box, and then I could submit 4 objects. If I don't know why anyone would want to do this, but I'm just using this for demonstration. I can also clear them all myself and then draw the boxes myself. And then my answer, whoops, I can move it. This is great. I love this. Slick UI. Excellent. Okay, and then enter. And then you see that my response is then going to be recorded with the bananas. So it's pretty cool to see that, okay, algorithm answered first, then we had cloud labelers, and then we had me as the user respond. So this is great.
Incidentally or not incidentally, user labels are treated as ground truth and used for k-fold cross-validation. So in case our labelers are not 100% correct, which humans often are not, we deduce customer intent solely from the user labelers or proxies that are vetted.
Yeah, that's great. Thank you for bringing up that idea of ground truths. And I think that's the great thing about Groundlight is that you have visibility on your model and you have the control and you can kind of dictate what your specifications are. And it's pretty simple to do so. So I think then that's a wrap for counting. And thank you so much, Amir. Thank you so much, Paulina. Again, if you have questions, you're welcome to reach out to me directly at julia@groundlight.ai. And I'm happy to help you assist in answering your questions. If questions are more technical, we're always happy to connect you with one of our applications engineer who can tell you how you can build your application or get you started. So we're very excited to be announcing this, and thank you so much for your time.
Thank you, everyone.
Yeah, thank you, everyone.
All right, take care. Bye, everyone.